All right, everyone, at this point, we're going to get this webinar started, and we're going to turn it over to Chase over at the Cook Dallas facility where they are on their showroom floor.
Hi, everyone. Thank you for joining us here at Cook Machine Tools Dallas showroom floor. My name is Chase.
And my name is Wesley.
Bear with us today as this is the first virtual tour we've done here at Cook, and I'm sure we'll stumble a few times.
Today we have collaborated with our partners at Methods to do an overview of a great product we have, the RoboDrill Plus K60. We would encourage anyone that likes what they see today, give us a call, come to our showroom, and we'll get you a personal demo.
If there are any questions during the presentation, please feel free to email your salesperson or send them through the chat soon. We'll be answering a few questions at the end, but if we don't get to yours, we'll be reaching out to you individually. With that being said, in the spirit of keeping it short and sweet, we'll hand it over to John Lucier at Methods, who will go over the highlights of the Plus K60 system.
Good afternoon. This is John Lucier with Methods Machine. I'd like to talk to you a little bit today about our FANUC RoboDrill automation, and we're going to feature the RoboDrill Plus K automation system as part of our discussion today. As I mentioned, my name is John Lucier with Methods Machine Tools. I work as part of the automation group. And before we get on to the automation itself, let's talk a little bit about the machine. Part of any great automation cell is having a great machine as part of it, and we're very fortunate as we've got the FANUC RoboDrill as part of our offering here. RoboDrill comes in 3 different sizes. You can see the sizes popping up there in front of you. Starting on the left-hand side, we've got the short bed, we've got the medium bed, and as you might guess it, on the right-hand side, we happen to call that one the long bed. It comes in 10K and 24K spindles, and this is a quick machine. We offer 14 tools. Most of the models are in 21 tool stations. We've got one of the fastest tool changes on the market today. Rapid traverse on this machine is 2,000 inches per minute. Typically, we make parts 20 and 50% faster. That's where a lot of our sales come from. People come in with a part or a program and say, can you compare this to the other machine that I already have? And like I said, we normally see that 20, 30, even 50% faster. This is a compact machine. It's also an operator-friendly machine. FANUC control, yeah, as you would expect on a FANUC RoboDrill, but we've got all the quick side screens. If you're familiar with those, that really make it easier to run. This is a reliable piece of equipment. We like to say bulletproof. It's designed for 3 shifts a day, 7 days a week for that automotive environment. The mean downtime between failures is about a day and a half over 10 years for machine components. That's outstanding. It has the most reliable ATC in the industry. Anybody working with machines with ATCs knows how important that is. FANUC recommends 5 million cycles before you have to do any maintenance to that. I've talked about how fast it is. It'll make a lot of parts quick, but you know what? It's also very flexible. It would make a great job shop machine. In automation, I've got a FANUC RoboDrill. Boy, does it hook up nicely to a FANUC robot. So that's the machine. To talk a little bit about automation, Methods has its own in-house automation group. We specialize in machine load and unload and integrate robots onto our equipment. We have standard offerings, one of which I'll talk to you about today. We also can do custom. So if you have something that just doesn't fit into the standard offerings that we're showing here today, we can build a solution around your needs. We put automation on most of the equipment that Methods sells. Kind of makes me smile when I read that because I don't get to say most. In our group, we put automation on any of the equipment that Methods sells. And I got kind of a neat statement here. Once you have a part, what else can you do with it? Once the robot has it, because we loaded it and unloaded it in and out of the machine, what other peripheral operations can you do? And frankly, Methods is quite good at that. We can air blow, clean the parts, deburr the parts, mark the parts, could be laser mark, could be pin stamping, could be inspection. All of those are things that we do as part of our automation group here at Methods. So back to the start of the show, the RoboDrill Plus K. You can see the RoboDrill on the left-hand side. The Plus K system itself is on the right-hand side with those diagonal yellow cut doors. In the front, the rounded door there, we open up and there's a carousel. On the side, we open up and there is a tool rack. This is it with the doors open. The Plus K is an automation system based around a FANUC robot with a FANUC RoboDrill. We can load pallets or different forms of work holding in and out of that RoboDrill, as well as tools. A system with loading pallets and this many tools will lend itself to high mix of mid to low volumes, and I'll explain that a little bit more as we go on. So through that side door, I said there was a series of tool racks. You can see right here, we've got 4 racks, 11 tools on each rack. And so that's going to add 44 tools to the 21 that's already in the turret of the RoboDrill for a total of 65 tools in the RoboDrill. Now that's not it. I got some more tools later. We'll talk about that in a second. But by opening that side door, the operator would load those tools up, close that door, and you can see the robot through the inside there would grab those tools and load that in. You go back to the front and you see the carousel. The carousel is really a uniquely designed, really convenient way to get parts, but also tools. So you see down here, I have rows of receivers that are actually holding parts. Could be vices, could be pallets. We'll talk about those in a couple of minutes. Or I could have receivers that are actually holding even more tools. So if that 65 tools is not enough to you, we can actually take away some of the parts and add additional tools to the system. So if you look over here on the right-hand side, there's a picture of the robot actually grabbing one of the vices that we're now going to load load into and take out of the machine. So that robot is going to go to the back side of the carousel, grab the parts that you've loaded, or grab tools and load them in and out of the RoboDrill. So back to that first picture, but now to describe it, through that front rotary door there, that's how you access the front of the carousel, and you would put your parts on the part receivers. And the side of the machine over there through the sliding door is how you would access the side racks. And that's where you get to the 44 tools that you have there. So one of the perceptions of automation is we make a lot of parts. When you do robots makes a lot of parts. Why put the money and time into purchasing and setting up a robot when you've only got a couple of parts to run? Why add extra setup time? One of the main reasons for that is automation really started in this country centered around the automotive industry. They're making hundreds and thousands of the same piece. There is no reason to spend any additional money on flexibility because it's just not necessary. They're going to make that same part over and over and over. As part of that, the robot is designed to pick up the part itself. Okay? Robots are generic. We can design a robot to weld. We could design a robot to blow cleaning fluid. We can design a robot to put adhesive on the window of a car. In the case of what we tend to do, we're picking up parts. So if we designed the sections of the robot to pick up the part around specifically picking up the part, if I change that part, it makes sense that I would also have to change how I'm picking up the part. Same thing with your work holding. If you design the jaws in your vise or your chuck to grab specifically that part, when I change that part, I'm going to need to change those out. In turn, when you run automation, you set it up for one part and you run out that one part. The Plus K is different. Okay? What we're going to do is have a common setup that allows us to load work holding. So if you look at here, I've got this little octagon that's mounted on the front of a vise. In fact, if I jump over to the third picture here, you'll see that octagon on the front of the vise. Here is the robot holding on to that octagon grabbing the vise to load that either in or out of the machine. So the robot is designed to load that octagon and whatever is attached to it. I don't care what the part looks like. It could be big, it could be small, it could be aluminum, could be steel, could be medical, could be aircraft. It doesn't matter to the robot. I'm grabbing the octagon, I'm going to move it in the machine, and when I'm done, I'm going to grab that octagon and I'm going to move it out of the machine. It's that common work holding scenario, which is what makes this system work. So again, as I mentioned, over here on the left-hand side, we've got the common transport carrier, which is the stop sign we call it. Here is the robot grabbing a vise with the octagon on the front of it. Notice on the bottom the 4 little pins. That's part of the 0-point clamping system. I don't know if you're familiar with that term, but what the 0-point clamping system is 4 pull studs. And if you look over here on the right-hand side, here is a plate, and I'm grabbing down and kind of holding that. That is my common clamping system. So whether I've got a big vise or a small vise or some of the other work holdings that you'll see on the following pages, I'm always going to grab that on that common feature. It doesn't matter what the vise is. It doesn't matter if I've got pallets or 2 big parts or little parts. I'm grabbing on those 4 pull studs. So while we can do this in a 3-axis machine or we can do this in a 4-axis machine, you tend to see this more often done on a 5-axis machine. Okay, so here's an example and a couple of pictures of the robot actually holding onto the vise and loading it into a RoboDrill with a 5-axis table. So the machine itself has 3 axes. This table has 2 axes. This is a direct drive rotary table called the DTT. It is direct in the 4th axis and direct in the 5th axis. And frankly, this is the fastest 5-axis table, 5-axis table on the market. If you're doing a lot of flipping around and milling different sides of the part, just by using a table like this, you can save yourself a whole lot of time. So to focus a little bit on this work holding, I've got a couple of close-ups. There's the vise, there's the octagon in the front of it, and you can see the shape of the hard jaws on the front of the vise. See, you get the little shape or the little step on the inside, and just like any other chuck, I could flip those jaws around and you see a similar shape on the other side. But if you look on the right-hand side, here I am grabbing a piece of stock. And what I'm doing is I'm grabbing that on a very little section, about 3/16 of an inch, okay? If you go back to the left picture, it may not show it well in this picture, but those are serrated. We're gonna dig right in and grab into that part and hold as tightly as we can with those serrations to allow us to machine as much of the part as we can in this one holding. That's what makes this system work. So if I break it down to a cube, I'm doing the left side in this picture, I'm doing the right side in the picture, I'm doing the top, I'm doing the back, and I'm doing the front. I'm able to do 5 sides of that cube all in one gripping. Okay, that's what makes this exciting. That's what makes this interesting. Now I would have to turn the part over, do the last side, but that's something I could do in a second operation. So that's the idea behind this, is we're trying to get 80% of that part done in one gripping. Now, if you've never done that sort of thing before, that might sound different. That might sound new. Does anybody actually do that? Or there's a whole industry around this sort of holding of the part. So if you look at the drawing or the picture on the left-hand side, there's a couple of different size vices. They can come from companies like Lang, HWB, 5th Axis is like that. All have tool holding that will go right onto the Plus K. If you look down here, this is a dovetail holder from a company called 5th Axis. And this is a Plus K ready holder right here. See the little octagon, and you got the 4 pull studs on the bottom. This is where, instead of grabbing on a little bit of the stock in a vise, you would use a dovetail holder, and you would have dovetailed the part first. Those are 2 different methods, either using the Lang or the HWV or the Methods vise there to grab on a little stock, or we mill the dovetail on it first. And there are a lot of people that do one or the other, and there's a lot of people that argue one is better than the other. My thought is dovetailing is great, but it's an extra operation. You actually have to put the dovetail on, then you put it into a machine like this, machine it, and then you got to take it off and machine it off and do the last side. So if you're able to hold it in one of those Lang type vices, it's one less operation if in the producing of the part. And the type of tooling that's available, you've got vices, you've got dovetail holders, you've got collet holders. There are custom made pallets. If you look at the third picture from the left here, this is where we were doing some impellers, and we actually made some custom pallets to hold the impellers. There are chucks. Mighty Bite has a whole catalog full of great little work holding things, and what you can start out with, and if you look over in this picture, this piece right here is just a hunk of aluminum. There's another one down here, another hunk of aluminum, where I'm gonna put Mighty Bite or different connectors or bolt pieces onto it, so you're able to make your own pallets, maybe a little bit more inexpensively than buying vices if that's not what you needed. Really an interesting holder. You see a picture of 3 of them right here, and another one right here in the Plus K is what we call a Christmas tree. This is actually a dovetail holder, but it's done in such a way in a cone that it's holding 12 different parts. So by holding 12 different parts, I'm really increasing the number of parts that I'm running there in one station. So here are some custom pallets. I don't want to spend too much time there, but you can see by holding in different directions, and all these pallets have that same octagon and the 4 posts on the bottom. Here is another collet holder we did. Here were some medical handles we were running for somebody, and this holder that we made would actually hold 2 different medical handles right in the same station. So the idea is to fill that carousel up. You've got as many as 60 stations. How many of these stations can we fill up with all different kinds of parts? Okay, so the idea, as I said, is to fill up that carousel. It could be some of the same parts, or it could be a mix of parts. Each station on the carousel could be scheduled to program with a program number and a priority for all the different parts. So if you have a high volume number of parts, there are some great automation solutions out there. But if you're mixing parts, you just normally don't think of that, to have a robot load a mix of parts, but that's what this is all about. By having the ability to schedule, and if you look on this picture of my carousel, here's one piece of work holding, here's a different piece of work holding, here's a different piece of work holding. So these could be all different types of parts that you're running. So if you don't have large volumes of the same part, this would work good. Or frankly, if you wanted to fill it up with all of the same part, you could also do that as well. Now, by having a number of different parts in the carousel, that's where having extra tools becomes very necessary. That's why you see the side racks with 44 extra tools, and even adding rows of tools, because boy, if I'm going to have 30 different types of parts in the RoboDrill at the same time, geez, I'm going to need a whole lot of tools there. And that's where the tool storage and loading capability of the robot comes in handy. Also, you might have 100 different parts, only 60 or maybe 20 in the machine at the same time, but having them all in the machine and all set up at the same time is where a carousel like this would be very helpful. So I mentioned that we can schedule. Here are a couple of pictures that are right on the screen. My pallet scheduler is right on the screen of the RoboDrill. Each one of these little blocks represents one of those stations on the carousel. If you see red, that means the pallet has been run. If you see green, that means the pallet is all scheduled and ready to run when you call it. If you see yellow, that means maybe I had a problem with it, maybe a tool broke, something like that. And if you see white, I'm not loading it. Down below here, you see the program numbers. Each different station. Station number 1 is going to run program number 4859. Program number, or station number 2 will run a different program number, and so on and so forth. I can also set priorities. Which pallet would you like to run first? Which pallet would you like to run second? There are some really great, full functioning, high-end cell controllers out there on the market. This is not it. This is just a simple pallet management scheduler, if you will. Okay, very easy to run. So I've got a little video that we've got here that shows the Plus K in action. Here's my RoboDrill, my DTT 5-axis table. You can see the red cap on the motor right there. So as I look through the RoboDrill, There's the carousel rotating till it comes to the first work holding that's scheduled. Robot goes over, grabs the vise. And I want to apologize. I know sometimes video through a Zoom conference isn't always the best thing. And this same video and several other videos of this system are located on YouTube. If you search out RoboDrill plus K, you'll see a number of our videos on this system and of several of the other systems that we offer. So here I am grabbing tools. So you've got a 21 station tool turret in the RoboDrill, which is still there and still active, but I have the ability to use the robot to take and augment the number of the tools in that, in that turret. So that could be a situation where I needed more than 21 tools on one part, or the extra tools could be for some of the other parts that you're running. There I am taking the vise back out. There I am taking the tool back out. There's the end of arm tool designed to grab both the work holding and also the tools. So the plus K can be configured in a lot of different ways. The way it comes standard would be 3 rows of parts on the carousel, leaving 2 open, and that side rack with 65 tools. So the standard is 65 tools with 36 part positions. A very popular way is to fill up that carousel with as many parts as you can. The carousel can fit up to 60 positions with 65 tools. In fact, that's such a popular method of getting that system. We actually have a separate model which is set up that way and can't be changed over, but talk to your salesman about that. They'll have better knowledge and brochures on that. That I can impart during this talk. But I can also add extra rows of tools depending on what you need. Now, by adding rows of tools, I'm actually removing rows of parts. So 48 would be 4 rows of parts, 1 row of tools. So that's 89 tools and 48 parts. If I go to 2 rows of tools, that's 113 tools with 36 parts. 137 tools with 24 parts. And if I want to go 4 rows of tools and only 1 row of parts, that's 161 tools and only 12 parts. Now, a lot of people say, gee, that's kind of silly. And I thought that was tool, but we've sold 4 of them just like that. So I guess that shows you how smart I am. One of the comments I would make on the 24 parts and 12 parts, when you start out offering 60 parts, to leave you only with 12 doesn't sound like a lot, but frankly, I've got several of our competitors in this line offering 10, 11, and another one's got 15 pallets. So frankly, to have 12 or 24 fits within the realm of them, to go up to 60 is just unheard of in that type of thing. So what type of work do you look at on a system like this? Traditionally, we look at 5-axis type work, but this is effective for 3-axis and 4-axis work as well, as I saw there. But it lends itself to that complex traditional 5-axis work, or it's simpler work, but you get more sides done in one operation. So if you see yourself with a part on your RoboDrill or similar machine, and then you flip the part and you do another operation, then you flip the part and you do another operation, can I hold it one time in a system like this and get 5 sides done? That's the thought, or that's what we see people doing with this type of part. Now, as I talked about before, we look at those vices are made to hold on minimal stock. So we're cutting material, we're slopping it in there, I'm grabbing it on that vise on that minimal stock, and I'm machining 5 sides. Benefits of the plus K: tools, tools, tools. It allows me to do complex parts, and it allows me to do many different parts without changeover. I could have over 100 parts or many even more parts with all the tools that I have available. And so when I get an order for parts, I know I've got the tools there and all ready to go. And I just go in and I go to that little pallet schedule and tell it, hey, call up this program. Pallets, 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 which means parts. I can get up to 60. Boy, that's a lot of different parts to put in the machine at the same time. Floor space. This system has minimal floor space. There is no other system that holds 60 pallets and this many tools in the floor space that we see there. In fact, there's a couple of them that we could put 2 RoboDrill Plus K systems in the same footprint as the one competitive system. No setup, okay? If you didn't realize that from what I said before, we're not setting this up. You're taking a block of stock, you're putting it in the vise, you're clamping it in, and you're putting it in there and you're running it. Now you might say, how do I run my program for the first time? I've got a slide on that in a minute. I'll talk about that. But with the 0-point clamping system and the robot grabbing that common transport feature, I don't care what the part you're machining, the robot, there is no setup for the robot, there is no setup for the machine. I'm simply grabbing a vise, putting into that 0-point clamping system, and off I go. No setup means you're making more parts. No setup means I'm able to do lower volumes efficiently. As I talked about on that slide in the beginning, why set up a robot in a machine to only do a couple of parts? I can just hand load those. Well, if I have no setup on the robot and I have no setup on the machine, frankly, I could do lot sizes of 1, and that's what this is all about. I can schedule many mid to low volume jobs to allow long unattended running all at the same time. So Camplete is a software product that works together with your existing CAM system to post-process, simulate, and verify your 5-axis tool paths in a 3D environment. I wish I could say I came up with that statement all by myself, but I just took it off the website. This Camplete 1 seat is included with each Plus K that we sell. If you've ever done the little first part dance, where you stand in front of your machine with a hand on the cycle start button and a hand on the rapid override button and your eyes looking through the inside of the machine because we don't want to find out that we made a mistake in our program. If I've got 60 different parts in my Plus K, can you imagine having to run all 60 of those parts? You don't do that. What you do is you use a verification software like Camplete, and you would use your existing CAM system if you already had one that you were familiar with. And what Camplete does is it takes one of the files from your CAM system and it post-processes it for you specifically for the RoboDrill Plus K. And then it's going to show you a simulation on your screen. The 3D environment is very, very accurate and very appropriate for what we have there. So if you made a mistake and I was going to bump off the 5-axis table or do something wrong or break a tool, I would see that within the realm of the 3D environment that it shows here. And frankly, now I'm verifying that the program that I ran ran correctly. If you're going to do 5-axis machining, you're not doing that by figuring programs in. You're using a CAM system. This just helps you know that the program that you wrote is correct and is going to produce a good part. Now, as good as that is, I'm not going to be able to tell you what finishes you're going to make on it. That's something you'll have to work on yourself. But that's a very, very important part of our solution here is Camplete. That allows you to program and verify that. So we worked together with Cook Machine, and you saw at the beginning where we had Wes and we also had Chase standing in front of a Plus K. We've got one of these things live on their floor in Dallas. If you'd like to see this thing in action, get a hold of your sales guy. Get up there and take a look at this thing. It's really an impressive piece of equipment. It's really different. Methods has a lot of high volume automation. That's traditionally what you see out there. And maybe in the coming weeks, we'll show you a little bit more about that. In fact, if you search out on YouTube what we had talked about, We've got the Plus K, there's the Plus E, there's the Job Shop Cell. We've got a lot of different automation products, but the Plus K is unique in how it handles the lower volumes or medium volumes. So as Matt had talked about at the beginning of this, I'm going to do a couple of questions. I see a couple of them come up here, and I'm going to talk about that. If you've got any more, use the chat feature there and just send them right in, and I'll get them. One of them, a question I see here, high mix of different parts with mid to low volumes. Can you elaborate a little bit more on ideal lot size? Great question. Low volumes, I would say, is anywhere down to a lot size of 1, because I don't have setup, I don't have to put tools in. So I could actually do one of this part and one of that part and one of this part over here. If you had a lot of different parts, low volume, that'd be great. Mid, where is that? Well, I've got 60 stations on the system if you purchase it with the most number of stations. Okay, I could put work holding in there and do all 60 of the same part. You also saw I showed you a couple of different work holding things that had multiple parts. There was a 2-piece and a 4-piece dovetail holder. If I take that 4-piece dovetail holder and put it on every station, I'm going to get 240 pieces. I'm able to load this up and run 240 pieces. That's not a bad load up. Okay, the Christmas tree holding 12 parts, boy, that's a whole lot of pieces. I don't see it very realistic that you're going to buy 60 Christmas trees and pop it on there and get but you're able to get, I think, a couple of 100 parts down to 1 part is what I think would be the ideal lot size. Now, where automation has not always been great is, if I've got a 10-minute or a 15-minute or a 20-minute cycle time, well, geez, why buy a robot to load that up? What you're getting when you get the Plus K is longer runtime for your spindle. I'm able to take a number of different parts and run all night long. So even low lot sizes, I think, are ideal on a system like this. Okay, another question. This is kind of funny. Why would I need that many tools in my RoboDrill? We have a 21-station RoboDrill, and we talk about having as many as 160 tools in the RoboDrill. Why would we need that many? Well, again, as I mentioned, by having a number of different parts, up to 60 different parts in the machine at one time, that's going to take a whole lot more than the 21 tools that are standard in the RoboDrill. So that's, we'd want to have that for running the many different parts. Also, those tools could be redundant. So if you've got a couple of roughing tools that are going through that, I could have 2 or 3 or 4 of the same tool in there. So I'm able to call up the redundant tools. Now, one thing I noticed somebody mentioned is it does take longer for the robot to load tools in than the tool turret on the RoboDrill itself, and that's correct. The tool on the RoboDrill itself will be a chip-to-chip time is about 0.7 seconds. That's quick. The RoboDrill is not going to open the door, take one out, put another one in even close to that. But it allows you to run all night long with nobody in front of it. That's what you're getting with that type of tool turret. I think that takes care of most of my questions. I see another couple of questions, but I think we're just about out of time. We're trying to keep this in a reasonable amount of time, and I'm a little bit more than the half an hour I was hoping to go with. We'll get back to you directly with your answers to your questions if you have any more. Again, my name is John Lucia with Methods Machine Tools. If you have questions, you can certainly contact me, but I would promote you to contact Wes and Chase and Johnny and Tim and Mike at Cook Machine, and maybe schedule to come up to Dallas and take a look at our Plus K and see if we can't, see if this isn't a solution that works for you. This concludes my part of the presentation. Back to you, Chase, Wes, and Trent.
Hi, I'm Trent. I'm one of the applications engineer with Cook Machine Tool. Thanks again for taking time. Let us show you the Plus K60. It's impressive to see in videos, but really good to see it in person. It's much better. So let us know if you have any interest. You can schedule in-person demo and come check it out.
Thanks, guys. Appreciate it.